Hello everyone. On this video we will be looking at the conic section of a hyperbola. Okay, so the general idea behind hyperbola is the fact that a hyperbola in this case has horizontal vertices and foci on the x-axis. Alright, so if you look at I didn't draw the x-axis because I didn't want to cover up all this stuff. But you have your center, your vertices are going left to right, and your foci are going left to right, so they're all horizontal. And in this case, if it's centered at the origin, 0, 0, then your left focus point will be negative C0, and your right focus point will be positive C0. Okay. Now you have the length of the difference between the distance to the two foci from a set point. We know that that's a fixed constant. Okay, so in other words, if you have a fixed point on your hyperbola, and we'll call that point xy, if you get the difference between distance number 1, which is from that point to one of your focus points, and distance number 2, which is the distance between that point and the other focus point, then that will equal a fixed constant. Okay, and in this case, we're going to let that fixed constant be 2a. All right, so using that information, we're going to come up with the formula for our hyperbola. All right, so if you're still writing this, of course, feel free to press pause and keep on writing. But we're going to go ahead and start on our proof. Okay, so that means the difference between distance 1 and distance 2 is equal to 2a. All right, well, since we're talking about distance so much, that means we're going to use the distance formula. And we know that our distance formula is the distance is equal to x2 minus x1 squared plus y2 minus y1 squared. All right, now, I'm just going to go back to our original page. If you notice, this is going to be our x2 and y2. So x2 minus x1 will be x minus negative c. So that's going to be x plus c. And y2 minus y1 is going to be y minus 0. So our distance 1 will be the absolute value of the square root of x minus negative c. So that's x plus c squared plus y minus c, which is y minus 0 squared, because that's our y2 minus y1, minus our distance 2. So our second distance, if you notice on that first page, goes from xy to the other focus, which is c0. So you have x minus x1, so that's x minus c, and y minus y1 is y minus 0. So that's going to be the square root of our x minus c squared plus y minus 0 squared. And the absolute value of that is going to equal 2a. All right. Now, if you look carefully, let me focus on that a little bit. There we go. If you look carefully, you'll notice that x plus c squared plus y squared is always going to be bigger than x minus c squared plus y squared. Okay? And that's only because we're dealing strictly with real numbers. If you're dealing with complex numbers, then that's a whole different story. But with real numbers, no matter what values of x, y, and c you plug in, this first term will always be bigger than this last term. So since no matter what, this is going to be positive, we can actually drop the absolute value symbols. Okay, so that gives us the square root of x plus c squared plus y minus 0 squared is just y squared. Y squared minus, now since we dropped the absolute value symbol, we're going to go ahead and just add this term to both sides, which means this is going to cancel out, and we'll end up with 2a plus the square root of x minus c squared plus y squared. All right, so now we want to start getting rid of the square root symbols. So how do we do that? Well, we square both sides. So if we square this side, and we square this side. Okay, so if we square the left side, the square and the square root will cancel each other out. And we'll be left with x plus c squared plus y squared equals, now if we get 2a plus this square root times 2a plus this square root and then do the FOIL method, we will end up with, let me clean up this equal a little bit, 4a squared plus 4a times the square root of x minus c squared plus y squared plus x minus c squared plus y squared. All right, so now what we're going to do is we're going to get these two terms and we're going to expand them. Okay, so this x plus c squared is just x plus c times x plus c, which once we do that and get the FOIL method will give us x squared plus 2xc plus c squared plus our y squared, which is equal to 4a squared plus 4a times the square root of x minus c squared plus y squared. Now if we expand this, we will end up with plus, because remember that's just x minus c times x minus c, and then we do the FOIL method, x squared minus 2xc plus c squared plus y squared. I barely made it on here. Okay. Now if you look really carefully, you'll see that if we subtract x squared from both sides, those two will cancel out. Okay. If we subtract c squared from both sides, those two will cancel out. If we subtract y squared from both sides, those two will cancel out. Okay. Now here, we can actually add 2xc to both sides. So 2xc added to this side, and we add it to this side. 2xc plus 2xc will give us 4xc. Now if we subtract 4a squared from both sides, we have minus 4a squared equals 4a times the square root of x minus c squared plus y squared. Let me bring that up a little bit. There we go. Okay. Now remember, we want to isolate our square root so we can get rid of it. So we're going to divide every term by 4a. Okay, so if you divide this by 4a, you get xc over a. You divide this by 4a, you'll end up with minus a is equal, and if you divide this whole thing by 4a, you get the square root of x minus c squared plus y squared. Okay. Now that we have our isolated square root, we want to square both sides. So that means we square this side and we square this side. Okay, so if we multiply this to itself and then use the FOIL method, we will end up with x squared c squared over a squared minus 2xc plus a squared is equal to x squared minus 2 xc plus c squared. Remember, we're just expanding this out because our square and our square root cancel. And we're expanding this one using x minus c times x minus c and then using the FOIL method. Plus y squared. All right, so now just to get rid of that fraction there, we're going to multiply every term by a squared. Okay, so if we multiply this one by a squared, we get x squared times c squared. So actually, before we get going, we can cut back on a little bit of our work, because if we add 2xc to both sides, those two disappear. So a little less work for us. So if we multiply this one by a squared, it's going to be plus a to the fourth. This one by a squared is a squared x squared plus a squared c squared plus a squared y squared. All right. So now what we're going to do is we're going to start shuffling them around a little bit. We're going to move some to one side and some to the other. So what we're going to do on this one is we're going to subtract this one from both sides, subtract this from both sides, and subtract this from both sides. Okay, so we have x squared, c squared. If we subtract a squared, x squared from both sides, this will cancel out. So we'll have minus a squared, x squared. We subtract a squared, y squared from both sides, we'll have minus a squared, y squared equals a squared, c squared. If we subtract a to the fourth from both sides, it'll be minus a to the fourth. Okay, so our next step is we're going to factor x squared from those two, and we're going to factor a squared from those two terms. So we have x squared times c squared minus a squared minus a squared y squared equals a squared times c squared minus a squared. So our next step is we're going to divide each term on both sides by a squared times c squared minus a squared. In other words, what's over here? Okay, so if we do that, we will end up with x squared, because we divided, the c squares will cancel out, x squared over a squared minus y squared, again the a squares will cancel out, over c squared minus a squared equals, anything divided by itself is just 1. All right, now quick side note before we do our next step. We know that since a squared plus b squared equals c squared, if we subtract a squared on both sides, we have b squared equals c squared minus a squared. So we can replace this. And we will end up with, let me move this over just a little bit. There we go. We have x squared over a squared minus y squared over b squared equals 1. All right, so we're running out of space. We're going to go ahead and continue this on the next page, and I kind of did that one ahead. So if you're still writing, of course, feel free to press pause and finish up. We're going to go ahead and move on to the next page. Like I said, I did that one a little bit ahead, kind of cut back on time. Okay, so this is where we ended up with. Okay, so we know this is our hyperbola with the foci and the vertices on the x-axis and centered at the origin. Okay, now doing a similar proof, we kind of switch some things around, which we're not going to do. But doing a similar proof, if we had the hyperbola with the foci and vertices on the y-axis and centered at the origin, you would have y squared over a squared minus x squared over b squared equals 1. Okay, now to get our generalized formula, okay, I'm going to move this up. So if you're still writing this up here, feel free to pause it. I'm just going to move it up a little bit. If you move your center h units horizontally and k units vertically, then we get our general formulas. So we have our x minus h squared over a squared minus y minus k squared over b squared equals 1. And remember, that's if you have your horizontal foci and vertices. Now, if you have y minus k squared over a squared minus x minus h squared over b squared equals 1, that's when you have your vertical foci and vertices. Okay, so they'd be one on top of the other, and this one will be one to the left and one to the right. All right, so once again, if you're still writing this down, by all means, feel free to press pause and finish up. We're going to move on to our next page. Actually, one more thing we want to do before we do that is we want to go ahead and find our papers here. I almost got my paper there. I'll pick that up later. Want to find our asymptotes. All right, so we know that x squared over a squared minus y squared over b squared equals 1 is our formula for our hyperbola. Okay. So first thing we're going to do, we're going to solve for y squared. So if we subtract 1 and add y squared over b squared to both sides, we get y squared over b squared equals x squared over a squared minus 1. Okay. Now if we multiply each term by b squared, we get y squared equals b squared x squared over a squared minus b squared. All right. So we're going to kind of mess around with that one a little bit. Okay, we're going to tweak it just a bit. So if we have y squared equals b squared x squared over a squared minus b squared, we're going to make that x squared over x squared and a squared over a squared. Okay, so technically we just multiplied it by 1. So now we're going to factor out the greatest common factor. Which means that y squared will equal b squared x squared over a squared times 1 minus a squared over x squared. Okay. Now remember a is just a constant. So think about x squared, your x value just getting bigger and bigger and bigger and bigger and bigger. Okay. So as x gets bigger and bigger and bigger, so in other words, as x approaches infinity, your 1 minus a squared over x squared eventually will get closer and closer and closer to being 1 minus 0. So this just approaches 1. I mean 0, sorry about that. Because you have a constant over a number that's getting bigger and bigger and bigger and bigger. Okay, so 1 minus 0 is just 1. So this is just 1. Oh, actually, I was right on that one. It should be 1 minus 0, which is just 1. There we go. That's a little bit clearer. All right. So if we square root both sides of our y squared equals b squared x squared over a squared, that will give us y equals plus or minus b over a times x. You can have bx over a if you want to, but I just brought the x out to the front. So you have y equals b over a times x, and y equals negative b over a times x. And those are your hyperbola asymptotes. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move to the page with all of the general formulas. Okay, so in general, if you have your horizontal vertices, remember they're going from left to right, this is your general formula. Okay. Okay, so we have a squared plus b squared equals c squared. Your center is at hk. The distance from your center to the vertex is a. So from the center to each vertex, each has a length of a. Now your vertices, if it's centered at hk, your vertices can be found by h plus a, k, and h minus a, k. So those would be your coordinates. Okay. Now you also remember that the center to the foci is, we're going to say that's c. So to find your foci actual points is h plus c, k, and h minus c, k. Now the distance from the center to your co-vertices, that's where this little square comes in. Okay, so you have your vertices here on the horizontal. Your co-vertices are on your minor axis. And in this case, that's called a conjugate axis. Okay, so the distance from your center to your co-vertices is b. I just didn't want to put all b's and a's and all that around here to make it too congested. Okay, now your transverse axis, that connects your vertices. So from this vertex to this vertex, that's your transverse axis. And that is equal to 2a. Remember, this length is a and this length is a, so you add both of them together, you got a length from 2a to each vertex. Now your conjugate axis connects your co-vertices, which are these 2 points here. Okay, so from the center to this co-vertice is b, center to this one is b, then b plus b will give you your 2b, which gives you the length of your conjugate axis. Okay. Now to find your points of your conjugate axis, starting from the center, you have your h, k plus b, and h, k minus b. And of course, we already know your asymptote generalized formula. Remember, the one that we did was centered at 0, 0. But if it's not centered at 0, 0, if it's shifting to the left, to the right, up and down, this is your general formula to find your asymptote. You have y minus k equals plus or minus b over a times x minus h. Okay, remember, these are for the horizontal vertices. If you have your vertical vertices, okay, remember your vertices are one on top of the other and your foci are vertical. Then these are the formulas you would use. Again, the a squared plus b squared equals c squared. Your center is hk. Again, your distance from the center to the vertex is a. But in this case, your vertices can be found by h, k plus a, and h, k minus a. So notice the difference. Let me move this over just a little bit. Okay, now the distance from the center to the foci is again equal to c, but to find the actual coordinates of the foci, notice the difference. You have h, k plus c, and h, k minus c. So you're starting at the center. Your k value goes up c, and it goes down c. Now the distance from the center to the co-vertices, again, is b. Okay, but to find the actual transverse axis is again 2a, but your a is the distance going up and down. Okay, your conjugate axis, again, is 2b that connects the co-vertices, but your co-vertices in this case go left to right on your conjugate axis. Okay, now your asymptotes, remember it's a little bit different for horizontal and vertical. For horizontal, this is your asymptote formula. For vertical, your A and your B are switched up. So it's, instead of B over A, x minus h, it's y minus k equals plus or minus A over B times x minus h. So there are little minor differences in your formulas when you're dealing with horizontal vertices and with vertical vertices. All right, but all in all, as long as you understand the concept up here, you should be okay. All right, so hopefully this made sense, and I will see you on the next video.